Students of B.sc Part 1, a respected listener, a very good afternoon and welcome all of you to today's lecture. Dear students of B.sc Part 2, I will deliver today Unit 5th titled as Chemical Kinetics of B.sc Part 1, Paper 3, Physical Chemistry, selected from that is of Unit 5th. Why I have chosen directly Unit 5th? Because in B.sc Part 1, it's some terminology will be used in Unit 1, Unit 2, Unit 3, Unit 4. I mean to say for that is of mathematical computer, real gases, ideal gases, liquids and solid. So first of all, I will deliver today. First of all, I choose that is of Unit 5th, Chemical Kinetics. I will deliver my lecture on that is of Chemical Kinetics. Dear students of B.sc Part 2, I think in our previous lecture, first of all, I bring to draw your kind immediate notice. I have discussed in the classroom in our previous lecture. Once again, I repeat about why the chemical kinetics is beneficial to define the mechanism, concentration, timings of that is of reactant product, and what is the role of chemical kinetics and how does it is beneficial and related to our daily routine life. In order to explain about the definition of chemical kinetics, first of all, dear students of B.sc Part 2, here I illustrate a very common daily routine life for the preparation for the cooking of tea. For the preparation of tea, we take, suppose we want to prepare 2 cups of tea. So I think for the preparation of tea, I take 1 cup of that is of water, 1 cup of milk, and addition of tea powder and sugar, and it will be heated. After certain period, after certain time, finally tea is prepared. In the same sense, as our daily routine life for the preparation of tea, various steps we have to undergo. In the same sense, there are so many chemical reactions undergo in various steps, in various paths, in various mechanism. Hence, chemical kinetics in compact form, I define here chemical kinetics, that is the branch of the chemistry which is mainly concerned the rate of the reaction, mechanism and concentration and its changing with respect to time is known as that is of chemical kinetics. Once again, I repeat, I define about chemical kinetics which is selected from that is of Unit 5, in which chemical kinetics, that is the branch of physical chemistry which is mainly concerned the rate of the reaction, velocity of the reaction, mechanism, concentration and with respect to timing is known as that is of chemical kinetics. Dear students, for a specific example I apply on that is of here, that is of a specific example. I am writing here on the blackboard here, in which 1 mole of N2 reacts 1 mole of O2 to produce twice mole of NO. You know, by single observation, it has been by single observation, it looks to us that when we mix 1 mole of N2, 1 mole of O2 to produce directly in a quick moment to produce that is of twice mole of NO, but it doesn't happen for the preparation of nitric oxide. The reactants I am using here N2, 1 mole of N2, 1 mole of O2 oxygen have to cross various types of the steps and mechanism. In the same sense, preparation of ammonia, 1 mole of N2, thrice mole of S2, twice mole of NH3, preparation of SO2 plus O2 twice SO3. There are so many reactions are known in inorganic and organic chemistry. By using, they undergo in various steps. The reaction may be molecular, ionic, the reaction may be that is of neutralized reactions, catalyzed reactions. I mean to say, dear students of B.sc Part 1, the final product is depending upon that is of steps. I mean to say that is of mechanism, concentration, timing. In order to explain the chemical kinetics here, I am writing here, I choose here a reversible example of chemical reaction in which 1 mole of A reacts 1 mole of B to produce that is of C mole of D. Here the kinetic curve has been shown on the graph between concentration, that is of timing here. When kinetic curve is plotted between that is of concentration and timing here, the shape of the curve will be obtained as shown on the blackboard here, in which the concentration of A plus B to persist is high and kinetic will start from that is of peak point, maxima. In reciprocal manner, the concentration of earlier T is equals to 0. C and D passes at that is of low concentration, and concentration of that is a product passes at that is of low, and curve will jump from that is of origin points here. As timings undergo, as progress of the reaction, as timing is changing, I mean to say here the concentration of A and B that is of decreases here, that is a negative sign, and the concentration of that is of C and D increases here. Concentration with respect to timing increases or decreases defined to add that is of whole chemical kinetics, in other words dependent upon that is of rate of the reaction. Here rate of the reaction or velocity of the reaction, dear student, first of all whole chemical kinetic I would like to define among the students. What do you mean by that is of velocity of the reaction? Here first of all I defined here, I would like to make the distinction between velocity and that is of velocity of the reaction here. Here suppose I remove that is of reaction, the rest quantity that is of velocity. What my question to all the students of B.sc part 1, how will you define that is of velocity and that is of velocity of the reaction here? Velocity is used in that is of physics here. The change in displacement or distance for any particle with respect to time is known as that is a velocity. Listen to me once again about the definition of velocity. For any particle, the distance is shifting with respect to timing for any particle is known as that is of velocity. In the case of rate of the reaction or velocity of the reaction, displacement distance will be replaced by that is of concentration. I mean to say the change in concentration either of reactant and product with respect to time or unit time is known as that is of rate of the reaction here. Now let us try here. Once again I repeat, in physics velocity, distance, displacement will be used here, while in the case of chemical kinetics, while in the to define that is of rate of the reaction, shifting distance will be replaced by that is of concentration. I mean to say here the rate of change of concentration with respect to time or unit time is known as that is of velocity of the reaction and rate of the reaction, and we will define and we will derive the dimension and unit rate of the reactions in coming tomorrow's lecture. Till then, thank you very much.